And then I started digging in other fields, and actually it's a truism that the biggest discoveries in any discipline are not discoveries. They're things that change how we discover. And so then I'm like, oh, I want to just look around and see what's out there right now that is a candidate for changing how we discover. But if you think of it not as automating, but as an aiding, I think there's two changes that happen. One, the autonomy goes back to the individual. It's aiding you to do what you want. And the second big change is it opens up a huge area of creativity. How can algorithms aid? What are the ways in which they can aid? And so I think that is what I'm hoping to see a lot more of.
So I keep hearing about this big promise of AI healthcare, including the type of things you talk about for by now, since 2016. So quite a while. So why this is not happening here?
Yeah.
So what is the breakthrough that we need here? So in particular, if you are Black, you tend to, on average, have harder access to healthcare. So there will be less spending on you. And that's something that the algorithm just picks up. So in particular, yes, so you already said this, but I just wanted to make sure we have it in the open. So what is the root of this kind of algorithmic biases? Where is it coming from? Is AI racist, or what is the reason? Hey, I'm Alexander Madry, and welcome to Before AGI podcast. Today, I have the pleasure of having Sendhil Mullainathan with me. Sendhil is a professor at the University of Chicago and someone who made a lot of breakthrough works in behavioral economics and AI. In fact, he's one of those people that you probably heard about their research without realizing that they are the person behind them. Sendhil is also a certified genius, as certified by his MacArthur Award, and an all-around amazing person. Looking forward to this conversation. Hey, Sendhil, how are you?
Hi, Alexander.
Let's get started. So tell me a little bit about yourself. Where did you grow up?
So I was actually born in India, in a little village south of Chennai. And I was there till about age 7. And I moved to the US at that point. So to Los Angeles, of all places.
From what I understand, your academic path started in an unusual way. So I think you were at Clarkson, then you dropped out, went to Cornell. So what's up with that?
I did not do very well in high school, but I was doing well in math. And at some point, even though I wasn't doing great in high school, I'd run out of math classes in high school. And so then I was like, I need to go somewhere to take college classes. So I went to this place in upstate New York that would let me take college class. So I actually didn't get a high school degree. And after doing that, then I went to Cornell. And so it was a very unusual path in that I think if you just looked at me in high school, I would have been like, I'm not good at school. But once I got to college, I'm like, I actually enjoyed this. I really enjoyed this. I mean, I think I really enjoy research and ideas. And high school is not really full of research and ideas. So life really felt good once I got into undergraduate.
But this brings us to another turn of events. So as far as I remember, at Cornell, you were a CS major. And then you made this decision where first of all, you chose to go for your PhD to do economics as opposed to CS. So that's a strike one in my book. But essentially beyond that, you chose Harvard over MIT. And that is truly bizarre. So can you explain?
No, I've got strike 3 for you as well, Alexander. I actually chose to do a PhD in CS at MIT. And I deferred it for a year to try out econ at Harvard. So I deferred, and then I said at the end of that, I'm doing this. It's a good question why I did that. I think it was, at that time, CS theory was really big. And that's what I was going to do. I was going to do CS theory. But also it just felt to me like theory at that point felt like it was getting increasingly removed from stuff. Do you know what I mean? Like it was starting to feel a little bit removed from things. And I think there was a tangibility in economics that I found interesting, but also a challenge. Like I didn't have the highest EQ. I didn't really understand people. And I liked the challenge of really trying to understand people. And so I sort of went into econ and said, I'm just going to commit myself to this. I just want to really understand people, learn a lot of psychology, learn a lot of stuff. And that's what I did. Yeah, I can't explain the Harvard choice. There's no defending some action.
Well, we all make some mistakes sometimes. That's okay. And by the way, for the background, as you realize, I also did theory of computer science at some point. Yes. So I guess the being removed from reality was not a problem for me. Yes. So that's fine. So you arrived to Harvard and then you chose to do behavioral economics. This probably was not the most popular choice, especially at the time.
Yeah, in fact, Richard Thaler, who would go on to win the Nobel Prize in economics for behavioral economics, I knew him as an undergrad And when I went to start doing my PhD, he said, don't do behavioral economics. That's kind of odd. He's like, yeah, that's just do some real field in economics, and as subterfuge, you'll do behavioral. I didn't listen to him, but it was, when I went on the job market, doing behavioral economics, it was a huge crapshoot. It could have gone any way. It was at the time, it's hard for people to believe now, even economists to believe now. Economists were so convinced that the rational choice model was the right way of doing things, that most of what you faced was kind of resistance, like true intellectual resistance, not the kind you can kind of argue your way around, but just resistance. And it was a sort of, I wouldn't say tough time, but a different kind of toughness. Like you just had to like brace it and just be like, I'm going to face some unfair challenges.
So it was upon you and your colleagues to prove to economists that people are not rational, they are rationalizing, and essentially what it means. So what is the work that you are the most proud of from that time?
Wow, it's a great question. Actually, as an aside, pride is a very tough emotion because it's tinged with things. And I realized the other day, so this is a really tough question. You've gotten to the heart of the matter. I was telling somebody the other day, which is that I don't think I feel much pride. And it's a bad thing because you work hard. You have to learn how to feel pride. And so I'm trying to learn how to feel pride. So if I were to simulate pride, I think the thing I should be most proud of is actually I did this paper, my job market paper, and it was a paper that was so weird. And I knew what I was doing was weird. And I should be proud of the fact that I was willing to so radically roll the dice. It was a paper about human memory. And it was saying, here's a formal model of human memory that captures what we know from the memory literature, that I'm now going to build one and show it has economic implications. But that's just an odd job market paper. You know what I mean? Like people are going on the market with things about, the industrial organization of the yogurt market. Like it's hard to compete with that when you're like, oh, human memory. So I think I should be proud of that. It was fun, but it was also a form of risk-taking. I guess I should be proud of the fact that I was willing to roll the dice. I'm not proud of it, but I should be proud of it. Yeah.
Well, just to explain to the listeners that actually in economics, you have this job market paper, which is essentially like the single piece of work that people evaluate you by when they think about hiring you. Well, you did quite well as a result. Like you ended up at MIT eventually, not for long, but eventually.
That's why I went to Harvard, so I could end up at MIT. That must have been the logic behind it,
I must say, I am an example. You can both do a PhD at MIT and be a faculty at MIT, so not optimal, but I understand you realize your mistake and you corrected it this way. Well, then you also became a faculty at Harvard, so maybe let's not go there.
Can I tell you a hilarious story about MIT?
Yeah.
After I chose to join MIT, between my PhD and my junior faculty member, I went to Chennai, also known as Madras. And my co-author, Marianne Bertrand, and I would talk to a bunch of government officials. And she would say, I'm a faculty member at Princeton, and I'd say I'm at MIT. And about 2-3 days into it, I realized whenever I said MIT, there was a kind of a weird look on their faces. I was like, why is that? And eventually I realized when I said I'm a faculty member at MIT, they all heard I'm a faculty member at the Madras Institute of Technology. So, so the second most famous MIT, I suppose.
I guess I will take that. So again, you corrected your mistake of going to Harvard by going to MIT as a faculty, but also you kind of corrected your mistake of going to economics by coming back to CS a bit later. So what brought you back to computer science after all?
Sort of brought me back was I finished this book, Scarcity, and when you finish a book, something happens in academia that rarely happens actually. So as an academic, you have work on like several papers. And when one paper ends, what happens? You get a little bit of free time to fill that slot. But because a book is so big, all the other papers have died out. You just have this. And when the book ends, you have nothing to do. So like I distinctly remember waking up one morning, the morning after I submitted my book, and I was like, I have nothing to do. And maybe there's another moment I should be proud of. I'd said to myself consciously, I'm not going to start doing something. I'm going to spend 6 months figuring out what to do with an explicit constraint of not doing anything. So then I started doing little exercises. They were actually fun exercises. So one exercise I did was I asked people in lots of fields, what's been the biggest discovery in the last 50 years in your field? And you started accumulating these answers. And what was striking was after looking at these answers, even fields even that I knew very well, like economics, the answers looked reasonable, but something was off. And I kept looking at them. So in economics, people would say game theory, behavioral economics, they give answers like that. And something seems wrong. And I realized what it was. It's that the biggest revolution in economics was the microchip. Because the microchip is what allowed people to actually analyze data. Without data, economics is a very different discipline than with data. Somehow that discovery was not apparent to them because they were living downstream from the consequences of this super important discovery, which is, let's not even call it the microchip, the ability to actually manage data sets of any size. And then I started digging in other fields, and actually it's a truism that the biggest discoveries in any discipline are not discoveries. They're things that change how we discover. And so then I'm like, oh, I want to just look around and see what's out there right now that is a candidate for changing how we discover. This is 2012, 2013. And at that time, supervised learning was starting to really take off. And I was like, oh, supervised learning is a fundamentally new tool for maybe changing how we discover. And so I was like, okay, this I want to go in on. So I was like, I'm just going to really invest in this, and spent a long time and it was fun to, because I'd done computer science in the past, I was like, oh, it's so fun to re-engage in this stuff. And it took time to learn, but it was very, very fun.
Sounds great. So before we come back to this, I just wanted you touch on your book, Scarcity. Can you tell us a little bit about this book, what it's about?
Yeah, so this is a book where I did a lot of work in development economics. And one of the things that puzzled me a lot is if you look across many, many areas, there's this unspoken thing that shows up again and again, which is the poor just make more mistakes. The poor just do more things that you look at and go, why'd you do that? So for example, I'll give some striking examples. If you think of diabetes in the 19th century, it was this truly deadly disease, and not in a good way. Because if you have too much blood sugar, you go blind, your fingers start to get whatever, they lose limbs. It's a terrible disease. So once we started getting these drugs where you could control your blood sugar, that was like a miracle. So now flash forward, you're like, wow, we've had this miracle. But still, there are about 100 and something thousand limb amputations in the United States due to diabetes. Completely preventable every year. 100,000 limbs being chopped off. Almost all of them amongst poor people. Not because the medication's free. So what's going on? It's because people don't actually take the drugs. And this is just a pill. For some people, it's like an injection, but that's it. Drug adherence. And that's just one example. The poor fail to take their medications. The poor fail to weed. And so you look at all this and you're like, how do you make sense of this? And of course, the elephant in the room, and the reason people don't talk about this is people want to say, well, here's a way to make sense of it. The poor are incompetent people. That's why they're poor, and that's why they do this stuff. But also, this doesn't look right. There are people who are just born into poverty. You can't say they're incompetent. So the point of scarcity was us trying to resolve this puzzle. And at least our resolution of this puzzle is that the arrow of causality runs the other way. When you're poor, it actually taxes your bandwidth. It actually makes it harder for you to reason. The poverty itself produces those circumstances. And the mechanism should be familiar to everyone. And you're very busy. You've probably experienced this. The mechanism is when you're feeling like you've got all this stuff going on. How do I make ends meet? How do I do this? Or you've got a lot of stuff going on. Oh, I've got these meetings. I've got this stuff. Those thoughts hang over your head and make it hard to think clearly. When you're trying to do anything, they keep interfering. And the poor often report this, that you just can't think. And so we have some research that shows that the same person, when they're poor, appears to be quite a bit less cognitively capable. And that's the point of that book, is that we just need to rethink poverty, not as a physical phenomena, but as a phenomena that affects how we think. And that's probably the biggest cost of poverty.
Okay, yeah, so that's fascinating, and I actually would love to dig more into this, but I guess we should kind of keep on the before AGI topic. So yeah, much of your work in CS is about algorithmic bias. So could you tell a little bit about what it is exactly?
Yeah, so I think that I'll start with the algorithmic bias literature as it sort of is, and then talk about my own take on it. I think the algorithmic bias literature is a reasonable and very needed reaction to a sort of excessive optimism that was probably there in the 2010s. It's like, oh, algorithms could do this, algorithms could do this. And then some people started noticing, sure, they could do that, but when we go and look at these algorithms, they seem to show some pretty strong biases, like I think the example that's most familiar to people is it used to be, Google's obviously fixed this. Some would say they've gone overboard, but either way, they've fixed this. But it used to be that if you just did Google image searches of a CEO, all you would get is white. Now, that's just it could hardly be that's the distribution of CEOs is all white and all male. But somehow that's what it used to look like. And so the algorithmic bias literature, I think, was an attempt to make sense of the fact that algorithms are going to have biases, whether it's a property of the data, a property of how they were trained, a way they reflect reality. And my own work in that has been to try and take algorithms that are out there that are kind of big and to say, okay, are they biased? And if so, what generates that?
Mm-hmm. So can you tell me, like, what to you are the most striking examples of algorithmic bias that you encountered?
Yeah, so I think one of the ones we worked on, I always kind of go back to as pretty striking. And it's that there's something called care coordination programs. These are programs that if you're going to be very sick, healthcare systems want to put you in. It gives you more resources, helps you navigate the system better. Mm-hmm. And the way people get assigned to those programs is there's an algorithm that predicts, are you going to be particularly sick next year? And this is already being run on hundreds of millions of Americans every year. And we studied this algorithm. And what we found is for the same level of prediction by the algorithm, Black patients actually end up being much sicker. Or put it differently, it looks like the algorithm is really under-predicting the sickness of Blacks. Mm-hmm. When I say really, let me give an example. If you were to equalize this disparity, you would double the number of Blacks enrolled in these care coordination programs. And since these programs are about how much healthcare this is arguably lives have been lost as a result of this disparity. So the magnitude of that was crazy. So I kind of find that surprising and disturbing. But the reason for it is also kind of interesting. When you dig into what's going on, because you can look, the nice thing about algorithms, unlike people, is that when you find a disparity with people, it's hard to know. But an algorithm's a piece of code. You can kind of simulate, do lots of things. What you find here is that the problem was these algorithms were trained, people thought, to predict sickness. But they weren't quite predicting sickness. They were predicting sickness as measured in insurance claims data, which means what they were really predicting is sickness as measured by utilization. Now, if you ask, I'm predicting utilization, the one thing we know is that Black patients utilize less care for every level of sickness than white patients. So by predicting utilization well, these algorithms are actually under-predicting sickness for Black patients. And so for me, that one I always go back to because it's got the two parts of both seeing the magnitude of the problem, but also the optimistic thing. Because when you see an algorithmic bias in an algorithm, you can diagnose it and you can fix it. Because now that we know where the problem was, fixes for this have been rolled out. So in the last, 4 years since this paper, things have now actually started being fixed and people have started putting better algorithms to work on this problem. And so I think that's an example I always go back to.
Okay, so there's a ton of delightful things to unpack here. So first, algorithmic bias essentially is this situation where the algorithm, essentially an AI algorithm, learns from data some representation of the world that might not be fully representative of its diversity, right? And this was this example in your case where kind of the CEOs tend to be white males, which is, I think, true that majority of them is, but doesn't mean that all of them are, right? But just somehow this mode takes over. So that's one thing. The other thing that you kind of point out in this example of healthcare, healthcare allocation, was that, again, usually these algorithms, like we take them to optimize for some objective, but sometimes we cannot measure a given objective. For instance, like how much medical care a given person should get. So we look for proxies. We look for, how much will it cost for this person to get the care? And then what happens, and this is an example you said, is that essentially, like in reality, we know there are disparities in access to healthcare. So in particular, if you are Black, you tend to, on average, have harder access to healthcare. So there will be less spending on you. And that's something that the algorithm just picks up. So in particular, yes. So you already said this, but I just wanted to make sure we kind of have it in the open. So so what is the root of this kind of algorithmic bias? It's like, where is it coming from? Is AI racist, or like, what is the reason?
I mean, I love that phrase you used about proxy. Let's actually dig deep on that, because the way you put it is perfect. Because I think a lot of people want to just blithely say algorithmic bias comes because the data is biased. But what does it mean to say the data is biased? Mm-hmm. I think the proxy example you gave is great. I think across many applications, what I'm seeing is that the biggest form of bias appears because we use a proxy variable. Or let's generalize this. We have objectives. Specifying those objectives in the data always requires making some accommodations. Mm-hmm. I don't know of a single instance where we're able to specify our objective perfectly in the data. We always choose proxies. We always say, predict this thing because it's a good proxy for what I really care about. That always happens. And that wedge is where I think a lot of bias shows up. And not just, I think that's where a lot of problems show up. I think that specification problem, that proxy problem that you described, and I'll give two metaphors. Let's stick to one. So there's this paper from the 1950s with a beautiful title. It's called On the Folly of Paying for A While Hoping for B. It's a paper about incentive schemes. This is a guy who is like, look, you give salespeople these incentives, but what you really hope for is this other thing. You give teachers incentives on test scores, and what you really hope for is learning. So in the literature on incentives, we know the folly of whatever. What I think your proxy point is saying is on the folly of predicting A while hoping for B. And I think that folly is the deepest sort of problem that we'll have to wrestle with, because I think it's in that distance between what we actually have as the specified objective in the data and what we care about that a lot of problems, and especially algorithmic bias, shows up. So I think the idea that algorithms are racist, it's not actionable. But I think we're starting to develop things like this where we know exactly where problems can creep in.
Okay, that's interesting. So actually, like tying back to some of your earlier work in economics, yes, like how would you compare algorithmic bias to a human bias, right? Like you had some works about the callbacks on resumes, depending on what is the name on the resume and so on. So could you tell us a little bit more about your work in human bias and how it compares to algorithmic bias?
Yeah. One of the projects I did at MIT when I was a junior faculty member was we sent out thousands of resumes for help wanted ads. We just applied to these ads with made up resumes. We made up thousands of different ones. But before sending them out, we put either a black name or a white name at random. And what we found was that resumes with black names or resumes with white names are 50% more likely to be called back, even though they're statistically identical. So that's a case that's like human discrimination, because that was in 2002. There's no algorithms in play there. And it's actually informative to contrast the healthcare bias example with the resume example. So take, for example, how hard it was to even find the bias. Mm-hmm. For the healthcare bias, algorithmic bias case, well, we needed access to the algorithm, but then it was just simulating lots of use case. For the resume case, we had to set up a little clandestine spy operation. We had to make up these resumes, send them, blah, blah, blah. It's hard to identify biases in human systems. It's much easier to identify bias now. And then let's roll forward to fixing it. 25 years later, there was just recently a very big study that redid the resume study by a team at Berkeley. And they found exactly the same effect. And you could say, oh, it replicated. No, it's not good that it replicated. We've had 25 years to see this thing. It shouldn't have replicated. We wanted it not to replicate. No one wanted the study to replicate. But the magnitudes are exactly the same. We've known about this. Human bias is hard to change. The healthcare algorithm found it, see the problem, we fix it. Doesn't mean there aren't other problems, but at least that was fixed. So I think a lot of the discussions about algorithmic bias, they correctly recognize how important the problem is, but they incorrectly fail to set it up against another big problem, which is human bias. When you put these two next to each other, I think you end up actually perversely more optimistic about algorithms simply because their problems are more amenable to correction in a way that human problems are not. We're people. People are hard to change, so.
Yeah, they are also inscrutable and essentially, again, hard to modify and all of that. So this all makes sense. But is this that simple? I'm all for being, optimist about algorithms and so on. But is that simple that you just identify a bias and you fix it?
No, yeah, I should say that you're right. You're right to call me out on that. I would say it's like anything. I'm taking these two things and putting them to opposite extremes. It's definitely not that simple. I think the only thing, just to illustrate, in some of these cases, the sellers of the algorithms have urges to resist because they don't want to be called. There's social forces that prevent it. And there's also the fact that, sure, we found this bias. Someone could correctly say, how do you know there aren't others? That's right. How do we know there aren't others? So it's not nearly as simple as that. But I do think, in contrast, the human one is super complicated. So I guess it's not 1 in 10, but 2.5 in 10. 2.5 is still bad, or 3 and 10. I'll give you 4 and 10, but 4 is still better than 10. And so in that sense, I think you're right to say it's not that simple.
Actually, let me push even further, right? Because it's not just a question of how do we fix it, how we realize there is a problem and we fix it. It's just, and this is actually your own work. Sometimes it's unclear what the fix should be, right? So there are things when people say bias, it's a little bit in the eye of the beholder what bias means. So like, again, you have work that exactly points that out in the context of fairness. So could you tell us a little bit about that?
Yeah, I think before I get to that particular work, I'll go back to something you said about proxy objectives. I think I've not done any work on this, but I think this is the first order fact. A lot of times when people look at things and they say it's biased, here's what they mean. That's biased relative to my objective. It may be biased relative to all of our objectives, but we each have different enough objectives that there's actually nothing we could write down that we would all agree on. And this is true especially when it comes to a lot of the racial bias issues, because in many applications, we don't have a social consensus on what the right objective, forget how to implement, forget the algorithm. We don't have a consensus on the right objective function. And so I think one of the things that algorithms are doing is because, take college admissions. In college admissions, we can have an unstated objective function because each admissions officer does something. They have vague words. We're looking for a class, a bouquet. How they implement it, who knows? So we don't need to come to consensus. Well, now if I were building an admissions algorithm, now things get weird. Well, are you willing to put a thumb on the scale for some racial groups? Should some racial group? Well, I don't want to discuss that. It's like, well, now we've got to discuss that. Well, because when you're doing it in your head, we never need to discuss it. And so I think that is going to be the biggest, that's going to be the biggest hurdle we face as a society. Algorithms force a level of explicitness that we may not want to have, that for better or worse, we're going to have it.
Yeah, so that's actually quite interesting. And actually, it also comes up to me in the context of failures of algorithms. Like if you think about self-driving cars, we just can get so upset if the self-driving car does any mistake. Like I was watching, there was the famous example where Tesla in the Bay Bridge tunnel kind of caused an accident. And again, it was an accident. It was clearly a mistake. But like when I look at the recording, I said, well, I've seen worse done by the human drivers, and no one it's not on the first page of news when this happens. So this ties to, so do you have some parallels that you can see between like how we think about these questions of bias and also questions of failure for humans versus the algorithm?
What a great analogy. In fact, the relationship between failure and bias is just not something that I really thought of. I mean, bias is one example of failure. So everything we were saying about bias should generalize to failure. And the self-driving car example is quite generative. So let's just do this thought experiment. Suppose I told you I had data. And in this data, I showed you some people were really bad drivers. And then we have to ask, how high accident rate should there be before we don't let them drive? Well, that's what we're doing with self-driving cars. What accident rate should there be before we say? And you'd say, well, wouldn't we do that for people? I'd say, would we? Suppose I showed you in my data, the people are people over 72. Are we going to consider taking all 72-year-olds off the road? That seems pretty extreme. Or what if we went further? What if we said, let's have hand-eye coordination tests for all people, irrespective of age? And maybe some people are not coordinated enough to be driving. These are not really options we consider with people because we don't hold people to some enormously high standard. But that's what we're doing in the self-driving car case. We're setting some ideal standard and comparing the algorithm to that ideal standard. And that's the analogy in bias as well. We're holding the algorithm to some incredible unbiased standard across all metrics. But we can't even imagine holding decision systems to that. So I think that's such a great analogy because what it's reminding us is that at some level, part of the problem in the algorithmic bias literature and part of the problem in the algorithmic failure literature is us not being clear enough about what is the standard. Are we applying that standard in some semi-uniform way?
Okay, so you did this wonderful job of like delineating all the difficulties of actually deploying algorithms in the real world for decision making. But then I do believe you are an optimist about that. So how should people, if I am a developer of an AI algorithm that I want to deploy for some decision-making task, for societal decision-making task, what should I do with these questions? Like, how should I handle bias? How should I approach this question?
Great question. I think part of what it is that people who are taught data science, machine learning, all of the fields, machine learning, statistics, they all start with the data frame. Given the data frame, given the objective function, how do you optimize it? Mm-hmm. All of the problems we see is in the mismatch between that objective function in the algorithm and that data frame and the problem in the world. And the missing skill right now is people who are able to look at the problem, look at the objective function and data frame that's concretely being used, and understand the gap. That skill is what every team really needs. I think in the sort of tech world, sometimes people say that's the role of the product manager, but often there is no equivalent of a product manager who also understands enough of how small differences in objective function can make a big difference. And so I think that if it's a particular developer, I think what I'd say is, great, put your developer hat over here, put on a product manager and ask, okay, in this real problem, what would be my ideal objective? What am I actually trying to come up with? What am I trying to do? And then red team, blue team, what are all the differences between the objective here and the abstract objective? And I think if you can reason through that wedge, that proxy problem, I think you'll know going in, oh, now I can see the problems that arise. And now, whether you decide to live with those problems or try to fix them, that's a conscious choice. Whereas I think what we've seen in the last 5 years is a bunch of mistakes that were no one's conscious choice. They're just things because there's nobody owning that bridge.
Okay, so I definitely agree that there is much room of improvement, but again, I think you are more of an optimist here than I am, which again puts me in an interesting position because yes, I think there is some epistemic challenges about exactly understanding how choices about the objective map into outcomes. But again, going back to your own work, sometimes we don't even we have a clear clarity of what is the fairness kind of objective that we might want. But again, everyone says we want AI to be fair. But then once you get to the details of what it might mean, you realize that there are big disparities and actually they are sometimes impossible to kind of reconcile. So can you tell us about that? What do you do then?
Yeah, here's why I'm optimistic. I think I'm optimistic because the detour into economics, that 20-year period, I think what it made me appreciate is without algorithms, just the world as it is, has many, many, many problems. And we actually have very few tools that do anything. That's the lesson in a lot. It's hard to change any social problems. So what makes me optimistic is not that I think algorithms are fantastic. What makes me optimistic is actually a different kind of pessimism, is that we have very few any tools that do much. So take this literature. We have some work that shows different fairness criteria are inherently in conflict. That you can't have the kinds of fairness, all the kinds of fairness you might have thought you would want. So that seems like a pessimistic work about algorithms. But to me, that's more a pessimistic statement, not about algorithms, but about our objectives. And many things I find come down to that. It's not pessimism about this particular tool for solving this problem. It's just the problem is hard. And that's what makes me optimistic, is against a very hard problem, even a small progress, to me, counts as real progress. And so if you feel like, look, I've got 3 fairness objectives, I can't satisfy all of them. I'm going to have to pick one. Okay, you pick one. I'm going to have to lose on something. Yes, you're going to have to lose on something. But then if in a real problem, you can make a little bit of progress, that's fantastic. Social problems are just so hard. I'll give a very concrete example. I think a lot of people feel like resume screening by algorithms is a terrible idea. I'm not sure it's a terrible idea because I know resume screening by humans is a terrible idea. So relative to that terrible idea, is a well-built algorithm a less terrible idea? Probably. And now we have to have tough conversations about which fairness criteria, which thing we want. But we weren't having those about people. And so we were having it symmetrically about people. We'd say, oh shit, we're not doing that right either. So I think that's the sense in which maybe I come across as optimistic, mainly because I'm super pessimistic.
I would not expect you to be a pessimist. I'm learning some new things. Okay, so trying to kind of zoom in on some specific domain, one of the spaces in which you do quite a lot of your work is in the context of AI and healthcare. Okay, so what is the promise here? Why should we be talking about AI and healthcare to begin with?
I think the promise I find the highest is not the one where I think a lot of research is going. Sorry, where most of the research is going is, let me get that out of the way, is let's call it automation.
Mm-hmm.
Radiologists read x-rays. An algorithm could read x-rays. To me, that's, saving some money. Maybe a lot of money, because there are a lot of radiologists. And some quality improvement, because everybody could get access to the best radiologists. Fine. But that puts a serious cap at where this could go. Like, it basically means we're going to have healthcare slightly better than now at cheaper costs, which is fine. I think the real big promise is in another area. And that area is, if you look at medicine right now, we just don't understand much. Just the truth of it. We have no idea. At every level. So if you say, I'm going to automate the reading of a pathology slide, which is kind of a tumor that we've taken out of the body, we've sliced it up and put it into images. I'm going to automate the reading of that the way a pathologist would, to say, is that tumor cancerous? That all feels like very scientific until you're like, but how do we know if a tumor is cancerous? The pathologist says so. The pathologist looked at it. They have criteria. Where do those criteria come from? When you dig, medicine doesn't, I don't think I'd be offending any doctors by saying, we don't understand much. The body is super complicated. I think that's the biggest gain that's waiting to be had right now, is our capacity to make new discoveries about all of the diseases that ail us. And I don't mean new discoveries like it has to be to find a drug. Even if we could better understand the morphology of a tumor that helps us know which ones are benign and malignant, huge gains in something as simple as that.
There is a lot of work also about trying to exactly automate not only like this, I would say, most direct task that the doctor does, like radiologist reading the x-ray. There's also a question of there is this mundane but very time-consuming work of like writing the notes after each of these things, which I think there are some successful startups that try to automate that. So there's clearly some gain, which I think everyone is happy about, being automated. But yes, so I keep hearing about this big promise of AI healthcare, including the type of things you talk about, for by now since 2016 or something. So quite a while. So why this is not happening yet?
Yeah.
So what is the breakthrough that we need here?
I think the big reason this has not happened is getting access to the kind of medical data we need. I think, let's do the pathology example. In the pathology example, you would need access to pathology slides, also long-term outcomes on what happened to those patients. The automating the radiologists and the notes, those are easier data. And I think that's why people pick those off, because those are data where you can get access to the x-ray and what the radiologist said. That's all you need. Or the notes, that's all you need. But this longitudinal data where you get both high dimensional inputs and outcomes, it just requires a lot of work to get. And the reason they require a lot of work to get, ironically, is not that they're not there. Many health systems have them. But working with health systems to get data out is just a lot of work. As you know, we had a project. You remember this? You remember this very well. We started a project during COVID to try and do something with COVID. And we got the data after COVID.
After COVID, yeah.
And that was a fast track project. So I think the biggest bottleneck has been data. And for me, I went in naively thinking, I'm going to do these projects. I'm going to start these things. And I've actually switched to saying what I need to do is actually facilitate everyone to get data. And that's where I've been putting my energy.
Okay, so why is it so hard?
We have a startup, Dandelion, and what we've done there, the experience there indicates, so what we thought was, let's just help everybody get this data. And what's hard about it is actually several layers. The first layer is that when you go talk to a health system, they don't know how much their data is worth. Also, getting you the data is 85th on their list of important things that are going on. So they're neither, even if they have a business development team, that's not a priority for them. So it's neither a priority, nor do they have any understanding of what's a good price to give you this data. Who knows? So what we've tried to do is to try and take all that and get a single contract with systems so that we can be the front door to these systems. But that metaphor is useful because we're the front door, the frictions are gone. Whereas I think, let me say this again. I think the problems are sociological in the construction of healthcare systems as the entities that are holding data. That's what I should say more crisply. It's sociological problems in the healthcare systems getting you the data. It's not that this is health information, it's private and it's secure. Those problems are very solvable. It's not, they don't want to give the data. It's just the sociology of the healthcare system.
Don't they believe in the dream that you are having, that with all this data we can cure cancer better and do all this? I think they, at some level, it is quite high on their priority. So what's not connecting there? Does it just feel too elusive to them? They cannot really fully conceptualize it?
With Dandelion, we've had a lot of success. We've gotten them to sign up, and now we have all that data. I think what's hard, I realized in starting Dandelion, was going to them with individual projects. Even if they believe that dream, that's like one small project for them. If they have a way to say, here's all of our data at once, these three systems have been willing to do. I guess another way I've come to see it in negotiating with these systems is the smart ones believe in the dream. The smart ones see it can be good for them, good for their patients, and good for society. But ultimately, their executive team runs a healthcare system. They can't be in the business piecemeal, one by one. And even if somebody comes in with a great pathology startup, that's one out of thousands of such things that could be going on. So I think it's more of a macro prioritization thing when these things are coming in piecemeal, if that makes sense. And I suspect other sectors, this will start to be an issue as well, because the power of AI is it can work on many different things. But the providers of data kind of can't be handling each of these piecemeal. That's just not what they do. That's not their business. That's not what they're built to do.
So essentially, we need more of a data market that really enables this kind of flow of data from people who have it to people who can do something useful.
That's exactly right. Yeah, and that's what we've been trying to do, and I think we need more things like that.
I'm looking for. So now you fix this problem. So in 5 years, I expect the cancer to be cured, right? So maybe let's make it 10 just to...
Sure. Yeah, 10. But let's do 10 with cancer and Alzheimer's. How's that?
That's great. A deal. Moving to yet another kind of space in which you thought about quite a lot, maybe pre-AI more than after AI, although actually you did both. It's essentially society, the societal uses. Again, decision-making is what our society does and what our policymakers do. So AI can help with this, but of course there are all these pitfalls. So how are you thinking about that? What is the role of AI in the policymaking?
Yeah, it's a good question. It's one that let me do decision-making and then do policymaking. So I think in decision-making, if you again don't start with the algorithm, but come at it from the person, I think the biggest innovations, like Danny Kahneman just died a few days ago, and his lasting contribution to humanity will be the emphasis on the fact that we as people make predictable errors and decisions and judgments. And that's a big insight, and one that has implications for everything we as people do, because as you say, decisions are everywhere. If that's the basis, I think one of the next things people are going to do is, great, if we're making predictable errors and judgments, how do we improve our decision-making? Mm-hmm. And I think that's a place where, coming at it from that angle, algorithms can provide an enormous value to that. I think right now we're in this period where people see algorithms as automating things. Mm-hmm. And if that's what they're doing, you can see why there's concern. But if you think of it not as automating, but as an aiding, I think there's two changes that happen. One, the autonomy goes back to the individual. It's aiding you to do what you want. And the second big change is it opens up a huge area of creativity. How can algorithms aid? What are the ways in which they can aid? And so I think that is what I'm hoping to see a lot more of. Work where we have basically, I think we talked about agents before we started filming, work that look more like that, which is, what are algorithmic agents, so to speak, that can help you decide or make judgments. And I think we're only starting to scratch the surface of that.
You definitely struck on a thing that I am a big believer in, that actually I think that we should focus more on AI assistance as opposed to AI automation. But could you give me an example? In what way AI could help me make better decisions and essentially just be an agent in my service?
I'll give you one, the ones I think most people will think of are things more like handle my email, et cetera. So let me do one that's radically at the other end of the distribution, which is back in medicine. Imagine you're a radiologist. You come in the morning, there's a bunch of CT scans that you have to read that have piled up overnight. So you start in the morning and you read your way down. the order you're going to read is first in, first out. But that's arbitrary. Like, it's pretty arbitrary. Imagine all you had was an assistant. It doesn't even need to be good at it. But it says, hey, these CT scans look like they could have cranial bleeding. Why don't you read these first? That small change, why don't you read these first, could have huge outsized effect. The reason is cranial bleeding every hour matters. So waiting 6 hours to get to it could have a huge effect. So there's so much of decision systems. Now you'd say, oh, that's a pretty unique case. Is it though? Think of a lot of decision systems. I'm reading resumes. There are 500 resumes. I know by the end, I'm definitely not giving it my full energy. So which resume should be at the top? The alphabetically first? The people who applied first? It's an odd thing. Simply an algorithm doesn't need to do a lot of work that just said, how do you want to prioritize these? And let me help you prioritize. I think that's an example of a proto-assistant activity that we don't even think an assistant could do, but could totally change many workflows as we see it.
I agree with it, but also I need to, again, push back. I guess that's my role here today. So when you say it this way, it all checks out. But like, I was reading this article about, I think DARPA was trying to use essentially AI for medical triage in the battlefield. And what was interesting there was the people's reaction to that idea. And they said, well, we can believe that this AI will make better decisions and be, really more pragmatic about things. But honestly, again, triage in the battlefield is a really messy business, meaning someone will die for sure and you decide who dies versus who doesn't die. And again, it's not about whether your decisions are correct or not. It's more about the families of these people saying, well, I understand it's a difficult decision. I would like to a human have done it so I can feel that they really feel remorse, or there's some empathy there, that just being decided by a machine just doesn't feel right. So in the context of this cranial bleeding, it's that's also someone's life. And yeah, maybe the algorithm did correct things, maybe they didn't. How would you know? Just so how do you think about that aspect?
I think that's one where I am genuinely more contrarian, I think, with where people are. I think people right now have the view that humans have pretty strong preferences against algorithms. My perspective is it's too early in a new technology for us to think people's views today is what they'll have in 50 years or 100 years. So I do this exercise whenever I'm giving a talk. I say, you're on a plane and you're about to land. The pilot comes on board, comes on the radio and says, hey, it's going to be a really bumpy landing. There's a lot of crosswinds. But luckily, we have an autopilot that can handle this kind of thing. So by show of hands, how many of you would want me to do it? And how many of you would want the autopilot to do it? And I actually asked people in the audience. And the reason I asked that is that when autopilots first came out, it's pretty clear. People were like, what are you, an idiot? You should do it. Now, many people in the audience are like, don't be a hero, man. Just turn on the autopilot and sit back. Many people. And so it's just a reminder that some of the aversion that we have to these things are well-founded. They're grounded in things. For example, I think when people say things like, oh, I don't know that the algorithm do a good job, what they're actually saying is, I don't know that the algorithm has actually got the full richness of objectives that I care about. That's not going to change, no amount of exposure. But I think a bunch of the reluctance just comes from the not yet familiar with the thing. So my favorite example of this is when the elevator first came out, people were very afraid to get into this thing for good reason. Mm-hmm. And so much so that when elevators become just you push a button, people are like, what do you mean there won't be an elevator operator? So they kept a person whose job was to push the buttons just so people felt comfortable. Now imagine you got into an elevator, there's just a guy pushing buttons for you. You'd be like, who's this weird guy? What's he doing here? So there's a sense in which I do think a bunch of this reluctance to algorithms is that. Not all of it. Some of it is very well grounded, but I think those stories are more common than you'll get in the future.
Okay, so still you are a big optimist, or you are saying less of a pessimist about algorithms, but it not always was the case. So I think in 2016, you were quite skeptical about current AI because you said it's driven by correlations versus causation. So could you explain what is the difference and why you were pessimistic
so
there? Are you pessimistic still?
I'm still very pessimistic. Yeah, I think I'm very optimistic about carefully considered problems for which AI has a place. I'm very pessimistic about this overexpansion of these tools into things where they have no particular places. So, for example, the reason when in medicine I was saying, look, a bunch of what we're going to do is in the diagnostic space is because diagnosis is about prediction. If we get into drug discovery, I'm sure there's great uses of AI there. But I don't think people realize at the end of the day, the core of drug discovery is going to have to be run a clinical trial. That's in the end, you're going to have to run an RCT. And the rate limiting step of that activity is going to be the RCT. We may get better at making guesses as to what to run an RCT on, because that's a predictive technology. But to me, the mismatch, the places where algorithms really fail, is when they're applied to problems where they're not fit for purpose. And I think the failure modes for me, maybe that's a way to summarize it. I see a lot of the failures that we see now is as using algorithms in places that are not fit for purpose. And I think we're seeing a lot of that. And when we can get rid of those use cases, we'll be left with something very good. But those use cases are really, I think they are very dangerous and very problematic.
Could you unpack it a little bit for me? So just you mentioned RCTs, which is randomized controlled trials, but like why it's good for what you say prediction, but not good for that? Like, could you unpack what is the core of the issue here?
I think a good predictive model allows you to say, if I see this, my best prediction is this. And we can build good predictive models because we've seen enough instances to form a relationship between input and output. Mm-hmm. To me, that's one category of world. Another category of world is where we need to run an experiment. We run an experiment by, in effect, introducing a kind of instance we've never seen before. We've never seen a person on this drug. Mm-hmm. Randomized control trials are very powerful in those areas where we simply don't have enough data to be able to say if X then Y. And so we must run a careful trial to generate data in those new instances. We've never seen otherwise identical person, one of whom got schooling and one of whom didn't get schooling. Because we've never seen otherwise identical people who are randomly assigned to schooling and not schooling. It's very hard from observational data because the people with schooling differ from the people without schooling. So to me, it's a subtle but super important distinction, which is when the data we have allows us to make truly apples to apples comparison, it's great for prediction. When the data we have doesn't allow us, we're trying to go from apples to oranges, we just need to collect more data, which is what a randomized control trial really does. And one-armed bandits and things like that in the online world are effectively that, because it's so easy to collect new data and to run new experiments. We can expand our data frame and we can keep going, and that works well. But for most social problems, there's a pretty big divide between those situations where our data allows us to meaningfully talk about causal things and situations where the data does not allow us to talk about causal things. We have to go and get new data, experimental data or something like it to talk about causal things.
So just to make sure I understand, so essentially what you are saying is, okay, we want to make sure that like when we try to understand the effectiveness of some drug, we kind of compare of like the outcomes of a person who never took this drug, maybe took a placebo versus someone who did. And just like that really allows us, as what you call is the apples to apples comparison. But for like, unless we do it by design, it will be very hard to approach it in the nature by itself. Like similarly, what you also mentioned with the schooling, that like people who usually get schooling usually also tend to have been, more wealthy and have other better outcomes, which kind of, so in the end, it's very hard to isolate specific impact of this particular aspect. So that's what you are talking about. So essentially, whenever we don't have enough of this data, then saying, be very careful with applying AI, try to do this randomized control trials or other ways in which we kind of try to be more careful about like the impact of particular aspects.
That's great. And the work you've done on sort of looking at things out of distribution, that even shows it's more than causation, even for pure prediction. When your data just comes from a particular sampling distribution and there's stuff you care about outside of that distribution, you should be equally careful. These algorithms are they're good for the distributions of data that they've been trained on. They're amazing at that. But we can't expect them to magically generalize outside of distribution. They may, that'd be awesome if they did, but you can't take it as fate that they're going to.
Exactly. In some sense, we train our algorithms on so much data and kind of we have this mistaken assumption that, okay, there's so much data, so all the examples are covered, but really the long tail of anything that happens is so large that we always are missing. So we always rely on generalizing kind of like distilling from the data some relationships that we hope will kind of hold on the data, but we have no way of checking it when we design the algorithm.
That's such a great metaphor about the quantity of data. I think the quantity of data somehow lulls people into not asking, fine, but what was the sampling distribution? So if I said to somebody, I had an online poll with 200,000 people responding, and from it, it seems clear the support for Trump is 10 points higher than the support for Biden. No one would believe that. They'd be like, what online poll? Who responded? Was it random sample? No one would be convinced by the quantity of data.
Mm-hmm.
But somehow, when we get into this world, people are like, oh, we have so much data. This must cover a lot of the case. Like, why? How did you get it? Where did it come from? Who posts stuff on Reddit? What kind of questions are asked on Reddit? What kind of questions are not asked on Reddit? So sometimes if you say, does the internet contain the world's knowledge? Does it? It'd be an interesting question to know. In fact, we should ask the question, what kinds of knowledge are not discussed on the internet? Is there any? I don't actually know. Like it's actually intellectually a super interesting question, but for a bunch of other problems, it's pretty clear. There are a bunch of things not represented, and we can't expect that magical jump.
So this is a little bit of a nerdy kind of analogy, but like, for instance, if you want to use AI to understand how to find vulnerabilities in software, right? Which might be something because you want to use it to fix bugs. And the problem is that like, it's very hard to learn from the internet how to find vulnerabilities in software because no one documents the process that actually gets there. Yeah, you can train on all of the internet and never get this thing, which, a security researcher every security researcher has. Just there's no incentive to document the process as opposed to maybe some
example. Yeah, that's a great example. Yes. That's great.
So, and it's actually interesting to think through like what are the things that are not on the internet. We worry a lot about things that are internet, and some of them are disturbing. Definitely, if you care about memes, then this is your right distribution. But yes, beyond that, it's quite interesting. So, trying to wrap up, I guess one thing I wanted to ask you is, what is your vision for the future? Like, you say now there is this tumultuous time where kind of people are getting used to AI. We are still developing AI, but like, let's say in 10 years from now. In 10 years from now, if you look back and say, okay, what was the impact of AI on the world? Like, would you say, is it a positive impact or maybe not so positive impact? Like, what is your prediction?
I guess since I should sit with my stereotype as an optimist, yes. I think
less of a pessimist.
Less of a pessimist. I think that we will see some super positive impacts that we'll be very amazed at. So that's the optimist part. I think we've talked about areas, health, scientific discovery, decision making. I think we'll see things where individuals in important decisions, in important situations, are just making better decisions. That benefits us all. I also think we'll see some nightmare scenarios play out, which are the kinds that maybe it's one of the scenarios people have talked about, such as the use of these tools for fake news. But I suspect it won't be any of those scenarios. I suspect it'll be a scenario we haven't yet game planned for. And if I were to say what I think is under-resourced, I think there are often scenarios where it's not about technology that hasn't been invented yet. It's technology, it's uses of technology that's already out there. Like, they wouldn't have to dream anything new, used by ill-intentioned actors in some super creative way. I wish there was more red team, blue teaming of just that. Let's not worry about what new tech might be coming around the corner. Let's just take what we could do in a basement or in a room for $1 million that could wreak some harm. And I don't think we're thinking enough about that. What is the crazy person, the Timothy McVeigh of AI look like? What does a country that's got some ill intent that's willing to put $50 million into AI, what could they do? And just some serious red teaming. Like, think of all of the energy that's gone into the topics that's out there that are known. Well, let's take 10% of that energy and put it into this. Like, maybe we can start thinking of what some of these crazy, and some of them will be very negative, like the Timothy McVeighs of the situations. There are going to be some really bad uses. I just don't know that I know what they are yet. I'm not sure any of us know what they are yet.
Could you say what is Timothy McVeigh's situation actually?
He's the Oklahoma City bomber.
Oh, I see.
But think of all he did.
He did not use AI as far as
No, he may have. He might have used ways to get there. I think it's a little early for that. what he did was, to my knowledge, and this is far enough away, I might be getting it wrong, but the principle of it is right. Got a big U-Haul type truck. I think the bomb was fertilizer and various things like, just took out an entire federal building, just with the truck, fertilizer, stuff you can buy. I think that's the thing we're not really considering. What can one crazy person or one crazy country with not that much resources for a country or a person, what could they do?
By the way, I completely agree with you. Just need to do more of this kind of red teaming and blue teaming of this question. By the way, the team I'm leading at OpenAI is doing exactly that.
Oh, fantastic.
It's trying to understand.
It's a Timothy McVeigh team? Is that how you refer to it?
No. We are just trying to understand how this technology can be misused, right? Like that's essentially, great. And important thing is technology that OpenAI develops, but also other people develop. And, big part of this is also like helping others who are not OpenAI in trying to exactly wrap their head around this. I'm not saying we've got you covered, but at least we are doing our part here. But and again, this is exactly antithetic to the whole idea of this podcast, which is before AGI. And actually, that's what I love. Just let's focus on this technology the way it is right now, because it changes things a lot right now. But yeah, don't you worry about AGI and about this kind of catastrophic scenarios that people talk about in that context?
I don't actually worry about that. Yeah, because I do feel the technology will keep improving, and exponentially, as you were saying. But I feel like where it's going to lead is going to be something unexpected. So, for example, I'm not even that interested in a human in a box. We have humans. It's fine. They're fun. They're interesting. But the thing about these algorithms is not that they can do human-like things. It's that they do things that humans can't even possibly imagine. So for me in 10 years, if you ask, what slope am I thinking about? I'm thinking about, wow, there's going to be something these algorithms can do that no human being currently can even imagine. And it's not about, imagine I could have 1 million humans in a box. It's just going to be a kind of intelligent capacity that is not a human intelligence capacity. And I feel like that's the most exciting thing about all of this, is not the replication of human intelligence at whatever scale, but the capacity to have a truly uniquely different kind of intelligence. And that seems very interesting to me. I don't know what it'll look like, but helping build that seems pretty exciting.
But that's exactly what AGI might be, like the singularity and kind of something that transcends who humans are as opposed to replicate. So I think that's part of the interest here, and kind of that's part why reason are excited about this. So you actually want to spend some time, hang out with AGI, because it will be interesting in a different ways than humans do.
Yes, definitely.
Okay, so this brings me to my final question is, again, if you think about AI, what personally you, Sendhil, are looking forward the most to or the least to? Kind of like
I'll do most.
Okay.
I think where I started this in 2012 is what I'm most looking forward to. I think science is the single most important force in human society, because at the 100-year horizon, it's what leads to the greatest progress on every dimension. The thing I'm most looking forward to is, what will science look like in 20 years when a lot of our fundamental tools of discovery have been transformed by AI? I just think we're going to see a scientific revolution that's at least of the scale as the one we saw in the first scientific revolution. I just think we're going to be on a totally different slope of discovery across many different disciplines, because I think science is going to change. That's what I'm most excited about.
I very much resonate with that thought. Thank you so much, Sendhil. So thank you so much for tuning in. We had the pleasure today to talk to Sendhil Mullainathan, who is a behavioral economist who thinks deeply about AI and what it means for us and the society. If you enjoyed this conversation as much as I did, please subscribe, share with your friends, and leave feedback in the comments. Thank you.